So density in normal sense means mass density. So you have to, unless you're talking about mass density, you have to specify what density is that. So here we're talking about number of that free electrons per unit volume. So the word number is as important as the other two words that we discussed. Okay. Then so the diameter is so there's we have a wire with constantly decreasing cross-sectional area, constantly decreasing diameter, and you are asked to plot the graph for the position along the wire. So x is here, so here is your x, and then your y is here, and corresponding to it is your y. Okay, so we are going to see how this drift speed varies with the diameter. So the drift speed when it enters here is Vx. Now we have this equation, I is equal to an, the drift speed, times charge, which means now they're talking about diameter. So in this equation, I is equal to an VE. I remains the same amount of current should flow through the entire conductor, so there is no change in the value of I. Area will be pi r squared, r will be half the diameter squared, times the drift speed times the charge, right? So in this equation everything else basically I is equal to pi d squared over 4 times v times e. So in this equation everything else remain constant. I is remaining constant, then the charge is constant. So if you consider how would the drift speed would vary with diameter, you can see that drift speed will be inversely proportional to the square of the diameter. It is like an inverse square law. So it is inversely proportional. That means when this decreases, that one is going to increase, but the factor would be inverted. So if the diameter becomes twice, then the d squared becomes 4 times and the drift speed will become a quarter. So if you look at how the diameter changes, from x it's d, then in y it is d by 2. So the diameter is becoming half. Okay, so diameter becoming half means d squared is becoming 1/4, right? If diameter is becoming half, then d squared is becoming 1/4. If d squared is becoming 1/4, then the drift speed would become 4 times, right? If d squared becomes 1/4, then the drift speed would become 4 times. So when you draw the graph, if this is x and this is y, and if your graph starts at Vx at x, then when you reach y it should be 4 times Vx. So the value should be 4 Vx, right? So from here you're going to go to 4 times of that, add y. But the issue is whether the change is going to be a straight line or a increasing gradient or a decreasing gradient, like this or this or this. Now you can see this is a relationship of now inverse square, right? So that means that you have an equation of the form where it is an inverse square. So if the compared to the density, the velocity would increase more rapidly. Hence, it should be a curve that is curving upward with an increasing gradient. When you have two quantities like this, like y equals, and just forget about the inverse thing for the time being. If you have a graph of y is equal to mx squared, right? If you have a graph of y is equal to mx squared form, you would have studied in maths, it would be like this, right? With an increasing gradient, because when x becomes like compared to x, y would increase rapidly. Now this is not of the form y is equal, okay, so that's the same thing idea here. Here also it is a relationship between a normal the power 1 and order 2 of the other quantities, so the gradient would be increasing. Now there is another question here. Now this is the pattern of the graph for a form of y is equal to mx squared. If you have y is equal to mx squared, then it would be like this. But what we have here is like v is inversely proportional to 1 over d squared, is like y is equal to m over x squared, right? Y is equal to m over x squared. So, but if you look at the graph I have drawn, the graph I have drawn still looks like a y is equal to mx squared graph, just like this one, right? We are starting from a certain value, that's it. Other than that, the shape is basically same. So how can the two forms could have the same graph? This is y is equal to mx squared. How can y is equal to m over x squared also have the same graph? Well, if you look at the x-axis, I have drawn x to y. Now, x to y means, if you look at the question, in the xy direction, in the x to y direction, the diameter is decreasing. So I have kind of twisted the axis. So x to y corresponds to decreasing direction of diameter. So diameter, if you consider the diameter is minimum here and diameter is maximum here. So I have, this is a kind of a strange comparison graph because I'm kind of drawing the axis like this. Not actually, but like drawing xy like xy here means you are drawing the diameter axis the other way, right? Because the diameter is dropping continuously along xy. So I'm drawing a graph of v in along the decreasing diameter. Diameter increases in this way means diameter decreases this way. That's why you still get the same shape, right? So be careful, this is not, now if you are going to draw a graph of v and diameter, then it will not look like this. It would be of y is equal to m over x squared. That would be some other shape. This axis here xy means x to y means we are talking about a direction. X to y is diameter decreasing direction. Okay. So yes, so be careful. We are not even drawing the graph between drift speed and diameter. We are drawing it between drift speed and position along wire. Now the position along wire corresponds to the opposite way in which diameter is changing. When the position along the wire is increasing, when it goes from here to here, diameter is decreasing in that direction. So it's quite a strange situation to conceive as a graph. But if you look at the mark scheme, not that much understanding is needed. So first mark you can score easily, that the line drawn with Vx and 4Vx at y. Then line has an increasing gradient. Now to understand the line is going to have an increasing gradient, this understanding about how this axis is functioning is not necessary. Simply when you see the square thing, you would understand it's going to be an increasing gradient. Okay,